So, hello everyone. In the series of revision classes, in now in today class, I will discuss one more chapter of physics that was motion in a straight line. So, today our chapter is motion in a straight line. Motion in a straight line, or you can say it as kinematics. So firstly, there are some basic definition that what is a mechanics. Mechanics is the branch of the physics that deal with the condition of rest or of motion of the material object. Okay. Next is your statistics. So what is the statistics? It is the branch of the mechanics in which we will discuss about the body when body is in rest. Okay. Next is your kinematics. The chapter is also of kinematics. Branch is of kinematics. So what is the kinematics? It is deals with the study of motion of object without considering the cause of motion. Okay, mean which we did not know what is the cause of the motion. But in the dynamics, dynamics is also a branch of a physics in which we study about the motion of the object. But in that one, we know that the cause of the motion. Now there are two cases. First is rest, and the second is of motion. So an object is said to be in a rest if it does not change its position with time, and if a body is changing its position with time, then it will said to be in motion. Okay. Now, firstly, I am writing the one definition that was of your rest. So, what is rest? An object is said to be in a rest. An object is said to be in a rest if it does not change its position with time. If it does not change its position with respect to its surrounding. With respect to its surroundings with passage of time. With passage of time. Second one is your motion. So what is motion? An object is said to be in a motion if it changes its position with respect to its surrounding with the passage of time. With the passage of time. Now next is your distance and displacement. So I can tell it by difference. Okay. So one is your distance and one is your displacement. One is your distance and second one is your displacement. So what is distance? It was the length of actual path travel. Length of actual path travel. And what is displacement? It is final position minus initial position. Final position minus initial position. Its SI unit is meter, and its SI unit is also meter. Its SI unit is also meter. Dimensional formula is L. Its dimensional formula is also L. Distance can never be negative or z. Distance can never be negative. Can never be negative. Displacement can be negative. Displacement can be negative or zero. Okay. Generally, the displacement is always less than or equal to distance. So the ratio of displacement and distance is always less than equal to 1. Okay. In the straight line, in a straight line, both the displacement and the distance are equal. So in a straight line, both the distance and displacement are equal. The distance and displacement are equal. Now next is your speed and velocity. Next topic is your speed and velocity. So speed is defined as distance upon time. Speed equal to distance upon time. And velocity is defined as displacement upon time. Displacement upon time. The SI unit of speed is meter per second, and the SI unit of velocity is also meter per second. Okay. Next, it is a scalar quantity. Because distance is also a scalar quantity. One more topic is left. One more point is left. It was a scalar quantity. Scalar quantity means which have only magnitude, and vector quantity means which have both magnitude and direction. So displacement is vector quantity, but distance is an scalar quantity. Okay. So velocity is also velocity is vector quantity. Now next is here its dimensional formula is LT minus 1, and it has same dimensional formula LT minus 1. Okay. So that was your speed and velocity, and generally displacement is always less than equal to distance. So if we divide by time both sides, so displacement upon time is less than equal to distance upon time. So displacement upon time is velocity is always less than equal to speed. So the ratio of velocity upon speed is always less than equal to 1. Okay. So that was the relation that velocity upon speed is less than equal to 1. Now there are type of speeds. Types of speed. Now first speed is uniform speed. Uniform speed. What is uniform speed? If equal distance covered in equal interval of a time. An object an object is said to be in a uniform speed, is said to be moving with uniform speed if it covers equal distance in equal interval of a time. Equal distances in equal interval of a time. In equal interval of a time. You can say uniform speed as a constant speed. Now I'm taking an example. This was a point. Suppose that was point O, that was point A, that was point B, that was point C, and that was at last D. So it was 10 meter in 2 seconds, 20 meter in 4 seconds, 30 meter in 6 seconds, 40 meter in 8 seconds. Now from 0 to A, O to A, what is its distance? Its distance is 10 meter. And what is the time required? 2 seconds. So here its speed is 5 meter per second. Now from A to B, its distance from O to B is 20 and from A to B is 20 minus 10. That distance is 10 and upon 2. So you will get 5 meter per second also. Now if you take from B to C, B to C is another 10 meter and in another 2 seconds. So here you will also get 5 meter per second. From C to D is another 10 meter. So another 10 meter have value 10 and upon 2 in another 2 seconds. So 5 meter per second. So if you see here, so it will cover equal distances in equal interval of a time. From 0 to A, 10 meter, A to B, another 10 meter, B to C, another 10 meter, C to D, another 10 meter. 0 to A, 2 second, A to B, 2 more second, B to C, 2 more second, C to D, 2 more second. Okay, that was your uniform speed. Second is your variable speed. Now next one is your variable speed. What do you mean by the variable speed? An object is said to be in a variable speed if it covers equal distances in unequal interval of a time. An object is said to be now is said to be moving with variable speed, moving with variable speed if it covers unequal distances in equal interval of a time. If it covers unequal distances in equal interval of a time. Of a time. Now suppose that was a line, single line, that is from O to D. So the point are here. Suppose that was your A point, that was the B point, that was C point, and that was D point. Okay. First is at 2 second, 0 to A 2 second, A to B another 2 second. That means 4 second from 0 to B, 6 second from 0 to C, 8 second from 0 to D. In the first half, suppose it covered 10 meter, and the second half it covered 25 meter. In the third half, it covered 39 meter. And in the fourth hour, it covers 61 meter. Okay. So if you take here, if you see here, 0 to A is 10 meter upon 2 seconds. So here will be speed is 5 meter per second. In the interval A to B, from 0 to B distance is 25 meter. So from A to B, the distance will be 25 minus 10, which is 15 meter. So 15 upon 4, which is equal to 3.75 meter per second. From B to C, the distance is 39 minus 25, means 14 meter and in 2 seconds. So here the distance is 5 meter per 7 meter per second. And from C to D, the distance is from O to D, the distance is 61 meter. So the distance from C to D will be 61 minus 39. 60 minus 30 will be 30, and 1 minus 9, 31, 9, 1. That is 21 meter upon 2 seconds. So that was 10.5 meter per second. So if you see here, that will cover unequal distance in equal interval of time. So we will get different values of speed. So that was known as your variable speed. Now next is your average speed. Average speed. So what is average speed? Average speed is defined as the total distance upon total interval of a time when it travel in a variable speed. So for an object moving with variable speed, moving with variable speed, the average distance, the average speed is the total distance traveled, total distance traveled by the object divided by the total time taken. Total time taken. So average speed is defined as total distance upon total time taken. Total time taken. Now come to the main part. So same definition is of uniform velocity. Huh? So if it cover equal displacement in equal interval of a time, then we can say a uniform speed. Now next is, if it cover unequal displacement in equal interval of time, that was your variable speed. And if it covers so if an object is moving with a variable velocity, the average velocity is defined as the total displacement travel about total time interval is known as your average speed. Okay, so same definition are in your uniform velocity, variable velocity, average velocity. Now come to the main part of the average velocity. Have two and three more concepts that are important for your exam point of view, that are come in your numerical part. Okay, so suppose first is your body cover different distances with different interval of time. Sorry, a body cover concept of average velocity. Now first one is a body covers different distances with different speeds, with different speeds. If the time is not given, so what we will do, suppose that was a single line, the distance is s1 here, s1 with v1. It covered distance s2 with velocity v2, speed v2. It covered distance s3 with speed v3, s4 with v4. We know that average speed is equal to total distance upon total time. We did not know time here. So what is the total distance? S1 plus S2 plus S3 plus S4. And what is the total time? We know that speed is equal to distance upon time. Distance upon time. So the time equal to distance upon speed. So the distance is S1. T1 equal to S1 upon V1. So if you add T1 plus T2 plus T3 plus T4, but here T1, T2, T3, T4 is not given. So I can write S1 plus S2 plus S3 plus S4 upon S1 by V1 plus S2 by V2 plus S3 by V3, S3 by V3 plus S4 by V4. That was your average speed. Now the second case is if it cover equal distances with different speed. If it covers equal distances, equal distances with different speeds. Now see the case that come in the question. Like suppose that was 2 point A and B. It covered S and S with speed V1 and V2. Either it came in the part that A to B is distance is S. So firstly, he goes from A to B, then with speed V1, and second it returns from B to A with speed V2. Okay. So when we cover equal distance, that means S1 equal to S2 equal to S. So with the speed V1 equal to V2, so V average means average speed equal to total distance upon total time, total distance upon total time. So what is the total distance in the both the case? S plus S. From A to B S distance, from B to A S distance, from A to O S distance, from O to B S distance. Time we did not know, so we can write T1 plus T2. But T1 is S upon V1. This time is equal to distance upon speed. So S plus S upon V1 plus S upon V2. Now S plus S is 2S. And if I take S common, so 1 upon V1 plus 1 upon V2. Now S will be cancelled. So the V average is equal to 2 upon 1 upon V1 plus 1 upon V2. Now if you add, so 2 V1 plus V2 or V1 V2 will be the V average speed when two equal distances cover in equal interval of a time. Okay. Now it comes also in the three part. Suppose that was 2 points A and B. It covered the first half at a distance OP at three equal distances, and it cover it by three different speeds V1, V2, V3. So T1 is equal to S upon V1, T2 equal to S upon V2, T3 equal to S upon V3. Now we know that average speed V average is equal to total distance upon total time, total distance upon total time. So what is the total distance? S plus S plus S upon S upon V1 plus S upon V2 plus S upon V3. So in numerator you will get 3S and you will take S common. So 1 upon V1 plus 1 upon V2 plus 1 upon V3. 1 upon V3. Okay. So S will be cancelled. So you will get V average as 3 upon 1 upon V1 plus 1 upon V2 plus 1 upon V3. So 3 upon V1, V2, V3. Firstly, V1 divided by V1, V2, V3. So you will get V2, V3 plus V2 divided by V1, V3. So V1, V2, V3. So you will get V1, V3. Third, V3 divided by V1, V2, V3. So you will get V1, V2. So 3 V1, V2, V3 upon V1, V2 plus V2, V3 plus V3, V1 be the average speed when it covered three equal distances with three different speeds. Okay. Now that's for your example. Now third case is if it cover if it covers different speed with different time, different speeds with different time, mean in that case you have not given any speed. Suppose that was the point B, point A. It will cover V1 with speed T1, cover V2 with speed T2, V3 with speed T3, and dash 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 Vn with speed Tn. Okay. So we know that speed is equal to distance upon time. Speed is equal to distance upon time. Here, the distance is not given. So distance is equal to speed into time. Speed into time. So for S1, we know that V1 into T1. Okay. So V average in that case will be S1 plus S2 plus S3 dot 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 Sn upon T1 plus T2 plus T3 dot 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 Tn. So S1 equal to V1 T1 plus V2 T2 plus V3 T3 upon T1 plus T2 plus T3 dot 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 Tn. Okay, Vn by Tn. Now, if it cover with equal time, no, if it cover with equal time, so what will happen? If time are equal, time are times are equal, so what will happen? So T1 equal to T2 equal to T3 equal to Tn equal to T. So V average is equal to what in the last topic what we have given. So V1 T1 plus V2 T2 plus V3 Tt upon plus Vn Tn upon T1 plus T2 plus T3 Tn. So V1 T1 plus V2 T2 plus V3 T3 dot 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 Vn Tn by T1 plus T2 plus T3 dot 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 Tn. So what we have given, the time are equal. So V1 T V1T plus V2T plus V3T plus dot 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 V and T upon T plus T plus T n times n times. So if I take T common, so we will get V1 plus V2 plus V3 dot 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 Vn by n by T. So if time are sorry, so T is cancelled by T. So if time is equal, so we get average speed as V1 plus V2 plus V3 plus dot 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 Vn by n as the average speed. Okay. Now the last topic is there, instantaneous speed. Instantaneous speed. So what is that instantaneous speed? So when the time duration is short, so that speed is known as the instantaneous speed. The speed of an object, the speed of an object at any particular instant of a time, at any particular instant of a time, or at a particular point of its path is called the instantaneous speed of an object. The instantaneous speed of an object. Speed of an object. V instantaneous is equal to limit delta tends to 0 delta x by delta t. So dx by dt. So the speedometer of the vehicle gives the instantaneous speed. Okay. Same in the case of average velocity. and instantaneous velocity. Now, next topic is your acceleration. With 1 minute. Next was your acceleration. Acceleration is defined as change in velocity upon time. Change in velocity upon time. So that means v minus u by t is known as acceleration. Okay. Now, its SI unit is meter per second square. SI unit is meter per second square. It is a vector quantity because velocity is vector. So that's why it is a vector. Okay. So it is a vector quantity. Next thing is dimensional formula is LT minus 2. LT minus 2. Now come to the next part. That was your equations of motion. Equation of motions. Equation of motion. And generally, the main part come in your exam is of by calculus method. Okay. Only that part is important, not other part. The simple method and easy method. Okay. So first is here equation of motion. So first we know that acceleration is equal to change in velocity upon time. So a dt is equal to dv. So when time is equal to 0, so the speed will be its initial speed, means it was starting with the speed, initial speed. When t is equal to t, its speed will be final speed v. So I am integrating it within a limit of t and v. Integrating within a limit of t and v. So a dt is from 0 to t is equal to dv from u to v. So a is constant, come outside, so dt is equal to 0 to t, dv is from u to v. So integration is removed by differentiation, or you can simply remember a formula that was integration x की power n dx is equal to x to the power n plus 1 upon n plus 1. Integration dt means you can write it as by t to the power 0 dt, because it is dt 1 dt. So t to the power 0 is 1. So t to the power 0 plus 1 upon 0 plus 1. So it is equal to t, or you can simply remember that integration is cancelled by differentiation. So integration dt is equal to t. So a is from 0 to t and dv is equal to v from u to v. So a, put upper limit t minus 0 and put upper limit here v minus u. So v minus u is equal to 80. V minus u is equal to 80 will be the first equation of motion. V is equal to u plus 80. Okay, that was your first equation of motion. First equation of motion. Now for second, s is equal to ut plus half at square. What we will do for second? We know that v equal to ds by dt, that the displacement upon time is velocity. So ds is equal to v dt. What is the value of v? U plus 80 dt is equal to ds. Okay. So ds is equal to u plus 80 dt. So when time is equal to 0, when t is equal to 0, so displacement will be 0. When t is equal to t, so the displacement is equal to s. So integration ds is from 0 to s and integration 0 to t u plus 80 dt. So integration ds from 0 to s is equal to integration u dt from 0 to t plus integration 80 dt from 0 to t. Now take the constant part outside. So integration ds is from 0 to s, u integration dt from 0 to t plus a integration t dt from 0 to t. Now integration ds integration is cancelled by differentiation. So 0 to s u integration is cancelled by differentiation 0 to t plus a t dt. So t to the power 1 means integration t dt. Integration t dt. T dt means t to the power 1 dt. So t to the power 1 means 1 plus 1 upon 1 plus 1. That means t square by 2. So it is equal to a t square by 2, 0 to t. Now if we put s minus 0, u t minus 0 plus a by 2 t square minus 0 square. So s is equal to ut plus half at square will be the second equation of motion. That was your second equation of motion. Second equation of motion. Now come to the third part, the third equation of motion. For third, we have a equal to dv by dt. Acceleration is equal to velocity upon time. So dv equal to a times of dt. Okay, sorry, wait. We have to multiply and divide by ds. Multiply and divide by ds on RHS. On RHS. If we multiply and divide by ds, so what will we get? A is equal to dv by dt into ds upon ds. So ds upon dt is displacement upon time, which is equal to velocity. So A is equal to v dv by ds. If you cross multiply, so you will get A ds is equal to v dv. A ds is equal to v dv. Now, when time is equal to 0, so the displacement is 0 and the velocity is its initial velocity. When time is equal to t, the displacement is s and its velocity will be v. So integrate within the limit of ds and dv, means displacement and time. So A ds is from 0 to v, 0 to s, and v dv is from u to v. So v dv is v square by 2. It is from u to v, and a is constant, so ds from 0 to s. So s from 0 to s, v 1 upon 2 v square is from v to u. due to v. Okay, v dv means integration v of 1 dv. So v to the power 1 plus 1 upon 1 plus 1, which is equal to v square by 2. So a s minus 0 is equal to half v square minus u square. So v square minus u square is equal to 2as. So v square is equal to u square plus 2as with the third equation of motion. So that was your third equation of motion. Third equation of motion. Okay. So student, that's all for today. If you have doubt in any topic of today class or of previous class, so you can ask to you can send that doubt or question to sir or ma'am, and then I will provide you solution in the video part. Okay, that's all for today. Thank you everyone.